Hello everyone, this is Ian. So in this video, I'm going to talk about the quad slice operator, which is used to quantify ngon faces and optimally works for angular designs. I'm going to do a separate video for grid project, but basically these two does the same thing, and that is to provide quadif faces for which the operators or random operator subdivision script will work on. So I have here a little base mesh to test to show the operator. So for example, if we're going to use loop extrude and we have limited dissolve on, you can see that we have a bunch of ingun faces. If we, for example, turn off for random loop extrude, turn off dissolve edges, you can see that we have the grid-like structure of the subdivided faces. Now, the random loop operator or random loop extrude operator has two solvers for the subdivision. One is with subdivide faces on and one is without. So let's turn this off. By default, this is the solver that is used by the operator, and the turning on the subdivide faces is the second one. Uh, if you turn this on, this is a much slower solver than it being turned off. So let's see the topology. Okay, so this is what we have. So the original solver for random lip extrude will only subdivide the edges. Or for example here, now we'll only subdivide the edges, and that is why most of the quadrant faces will be on the side. You can see here, most of the quads are on the side, but on the top are a bunch of ingons. And this is what we have without limited dissolve, uh, with limited dissolve off. So it's kind of filled with a bunch of useless verts that you just that is better removed than of course kept. And the second solver with subdivide faces on will of course subdivide the faces in a normal way, which is grid-like structure like this. So that is the two solver of the random loop extrude. So let's try subdivide faces, and let's turn on ignore border faces so it doesn't extrude on the sides, and it will only extrude on the top faces. And let's turn on dissolve edges. So I showed you that because you can actually keep the quad structure with subdivide faces on and turn off dissolve edges. However, if you have subdivide faces off, then you're better off using the limited dissolve to get rid of the useless verts. So with limited dissolve on or dissolve edges on, which is using limited dissolve, get rid of the vertices depending on the face angle. you'd have ngons. Now, if we use the operator here, it will not subdivide because the subdivision kind of works like the subdivision command here. If you use this on a quad struct on a ngon face, you can see that the faces are not subdivided, but the edges are subdivided. However, if we use subsurf modifier, simple, and let's turn on wireframe. It subdivides the ngon faces, but rather messily, of course, but it does subdivide the ngon faces using the subdivision modifier. However, the VPY version of the command does not do that, and it needs either the faces to be thrice or quadded in order for them to be subdivided. And that is how the subdivision in the random operators work, and that is why they need quad or triangle faces too in order for the faces to subdivide. Okay, and that is why we have a grid project and quad slice. So you can see in my video, as soon as I use the random loop extrude, and I see an ngon face or ngon faces, and I need to use the random operators on that, I either use quad slice or grid project in order to give me some quad faces for the random operators to work with. Okay, so okay, let's. You can you of course you can manually dissolve the verge using this X. For example, we have this, so X, and then limited dissolve. This works the same way as the dissolve edges. I should probably rename this um, dissolve selected edges and vertices. Dissolve edges, dissolve verts. I think this will be better if dissolve verts or dissolve edges and verts. Should probably rename this to make it more transparent. Okay, so in order for me to qualify this, I'm going to use quad slice. I've selected the ngon face and then quad slice tangent. And I'm going to use linked faces in order for the cuts to only affect the linked faces and leave the rest of the geometry alone. So if I use all faces, you can see that the cuts from the selected points in the ngon face or selected verts in the ngon face have affected all the faces in the mesh. Whereas if I use linked faces only, then it will only affect the faces that are connected to these selected ngon face that I have from the start. So you can see there, here is affected this face here. But if I use selected, then it will only affect the selected face here. If I were, however, if I have two selection and I use linked faces, let's slide this here. So you can see that uh, this island here also affected this island here. And you can see that this point cut this line here. So in order to actually just limit the cut to a single island, you should just quadify islands individually if you want to avoid them affecting each other. Same here. And we need to use, okay, there we go. So when I qualify this, and then kind of add, now now that I have it mostly qualified, I can use tools like random loop cut, which only works, not random loop cut, I'm sorry, loop cut, which is control plus R to add loop cuts, and it doesn't work with in-gun faces. You can see control plus R doesn't highlight, whereas in a quad face will work. And then I select a face and then use the link flat faces command and then go to object mode and use the random operators. Now their subdivision will work because the faces are quadified. Except for this one. I think this works even if the uh yeah, subdivision. Except for the random scatter, this can work on all face topologies from ingons to quads to tris. But the rest needs qualified faces in order for work to work. For their subdivision to work. Okay, let's do another sample here. So I select the top face and then quad slice tangent. So what does tangent mean? Tangent means the longest edge in the selected face. So what is the longest edge here? This one. So why do we need the tangent information? We need that in order to provide us with the XY axis. So if I cut this, so we have the Y cut and the X cut direction. And you can see if I limit the cut to X only. So this doesn't necessarily because we are getting the information from the tangent, sometimes our orientation does not necessarily match the uh, the axis that we see here. So for in this view, of course, our x-axis is this direction, and our y-axis is that direction. But for the tangent information, this is the x-axis. So that's the x-axis, and this is the y-axis. And if we set the limit to none, it will cut on both directions. So the tangent, the longest edge in the selected face, gives us the necessary directions in order for the to for us to in order for script to work out which directions to cut. And view is this the viewport. So the x and y axis is determined by the viewport. So this is the y axis and this is the x axis. And it depends on the way you look at the face that you've selected. So for example, if I cut it here and use view, you can see that That's our y-axis and that's our x-axis. Let's see. Oh, okay. So actually in the script, this is the direction is correct, but again, it's um it's still connected to the normal of the face, and the normal of the face that says that the x direction is that way. Which for us, of course, if we look at the wait a minute. Oh, that's correct. The x and the y. Yeah. Sorry about that. Got a little brain fart there. So that's the x and that's the y. But if you see the directions, of course, not a line, or the x is this way, it doesn't matter as long as it cuts correctly, because it depends on the normal of the face, and sometimes the normal of the face says that x is that way and y is that way. So looking at another angle, F9 to bring the undo menu back. But if we look at the face straight, there we go. So there is a shortcut for looking straight at a face. So Shift numpad 7. It also works on edges and verts, and it will look at them based on their uh, Z normal direction. After pressing Shift 7, the viewport might be confusing to fix. Just press 1 to go to front mode. 1, 3, or 7. 1 is front, 3 is side, 7 is top. So I usually just use 1 or 3 to fix the viewport after I use Shift 7. If tangent doesn't give me the necessary directions at all, and I have to use the view, then I use Shift 7 or manually navigate the viewport to face the face direct the face to face directly, or face the polygon directly in order to use the view direction and get the necessary cuts. But the only um, disadvantage of using the view direction is, so for example, if I cut it this way, or if I cut it correctly this way, and I haven't done anything, I can bring back the undo menu using F9. But when I switch the view, and then and then probably limit the cut to X, you can see that the alignment of the cuts have changed because the view have changed, even though we just recalled back the operator. So the operator is still uh, so when you call back the operator, the script runs again, but because the view has changed, then of course the cut has changed. So if you're cutting, if you're trying to, if you're cutting using the view, try not to change the the orientation of the viewport once you've settled on the correct one, while you're modifying the rest of the properties. Okay, so view, but if we change the view to here and press view again, then we have this. So verts, the origin, verts, which means that the cuts will be sourced or will originate from the vertices of the selected face. Edge, will source the cut from the edges. Just kinda wait. Okay. Doesn't work on. You have to go to edit mode or face mode in order for this to work. This is the first time I actually seen that happen, so I have to correct that. Okay, so we select this edge, for example, and use edge. We have to select the tangent. You can adjust the factor. So let's try something on the box. This one. So I think this will be our longest edge. There. You can see that it followed this edge because it's the longest edge in the face. Edge. So what is the tangent number? So the tangent number here in this, you can cycle, you're cycling through different tangents. So what is the tangent in this case? So the tangent in this case is the faces, the linked faces in the verse that you have selected. So we have this face, this face, this face, and this face here. So when you use it to cut edges, you are cycling through those faces. So we have 1, 2, 3, and 4. 1, 2, 3, and 4. That's connected to the selected words. So 1, 2, 3, and 4. 1, 2, 3, 4. And then when you go to 5, it will cycle back to 1 again. So for example, if you have 6 linked faces from the verse selected, then number 1 will cycle back in 7th. Okay? So here we have 4. So 1, 2, 3, 4. If you go to 5, it will cycle back to the first face using its tangent or longest edge in that face, and then 8, and then 9, back to 1 again. So if we select only a vert, then the tangent shows up. If we select a face, actually the tangent also shows up. Wait, oh, the face shows up. The face property shows up. Sorry about that. There we go. So vert. So again, the tangent in this case is the tangent information of the linked faces from the selected vert. So we have this selected. So 1, 2, and 3. So what are the longest edges on those faces? On this one, this is the longest edge. On this one, this is the longest edge, and this also. And this one here is perfectly square. So all of them is considered the longest edge. So what about the face property when I select individual verts? So if we use all faces, the face property disappears. Linked faces, it doesn't appear. Shared face, meaning that since this face has all these linked faces here, then you can choose which of those faces to cut. But of course, they're perfectly aligned, so we're not seeing much words. There we go. So you're basically selecting which face to cut. from the length faces of the selected vertices. So, but for example here, but it doesn't work. The face property doesn't work like the tangent, which takes into consideration all the length faces from the selected vertex. So from these two, 1, 2, 3, and 4, 1, 2, 3, and 4. In the face, if we selected those verts and the face property shows up, showing us, letting us choose which face to cut, you can see that it's only cutting this face here and here. So why is that? So the way it works that is that the more faces you select from a single face, it will home into that face, to that face only. So we have two verts selected here that have two length faces. They are sharing two length faces together. So this one here has this length face here, this one here has length face here, and this one also has this length face here that is connected to this verts also. So they will only cut those and not cut this one and this one. But if I choose three verts, now I'm homing in to this ingun face in particular. You can see that when I cycle, it's no longer cycling through multiple faces because now these three, as long as we have more than two, now we have honed in to a single face right here. So it doesn't cut here because this one is not sharing that face. It doesn't cut here because this one is not sharing this face. And it will only cut this because these three are sharing this face. So the more verts you select to a face, the more it will home in on that face and only cut it. Whereas a single vert will cut that, and two verts, three verts. See? So I hope it's not that confusing. But if you select a face, then the face property disappears because, of course, it will only cut the face that you've selected. You will already selected the face that you're going to cut. Okay. So we have rotation. Okay, let's go back to the test model. So what else? Tangent, edges, we have that, and tagged. XY rotation. Let's do tagged. So tagged means that it will only cut from the tagged verts using the tag verts command or operator. So for example, if I tag this and this, let's create a better example. Try and create a better example. Longest, shortest. That's chaos. Quad slice. here. Um, Actually, this is a much better example. Let's offset this a bit. So if you select this face and then use tangent, you can see that since the tangent information is quite straight, this uh, offset uh, side here also went and also made this cut here, but we don't want that. So in order for us to just limit the cut to a few verts, so let's just select this. So we only needed this one to quadify this face anyway. So tag this vert and then quad slice, use the tagged, and then linked faces if you want to cut the island, or all faces if you want to cut the entire mesh. But if we use verts, you can see that it used all the verts in the selected faces to cut the face or the mesh, whereas tagged we can control it. So be careful with the tag command. Once you select something, once you tag a vert, then those two are tagged. If you select a new one and then tag them, it will replace the old tag verts with a new one. Okay? And they go on the tagged verts Q slice vertex group in order for the script to properly call them. So if I tag this and let's select it. So if I tag this, select it, select it, and you can see that it replaced those two. So let's cut this to here. Oh, trying to search for a. Actually, this is all angular, so probably not the best example for the um tagged, but for something like this. So if we use all the verts, oh, that's the longest edge. Wait, okay. Quad slice and use all the verts to cut. You can see that this one cut there also. So we can just deselect this and tag the rest of the verts and select these faces, quad slice and just cut from the tag. You can see that this one did not cut straight here. So you can use the vert tagging to limit or control the cuts from the tagged verts only. And let's go to we have rotation and distance, remove doubles, yeah. Rotation, distance, remove doubles, and remove two edge verts. Okay, let's create another cube. Quads, quad slice. So rotation, 45 degrees. You can actually use this to, uh, if this is the longest edge, for example, let me cut that. We can use this to, um, based on the tangent edge, redirect the cuts or rotate the cuts. Let's try this one. This is our longest edge. Selected our linked faces. And let's try to straighten this up. So it's kind of hard straightening this because we're not robots and we can't really figure out the exact rotation in order for the to avoid doubles. Here you can see that this may look like a single edge, but there are actually two edges, and they're bad for subdivision. There. So what we need to do is mix it with distance. The magical distance of property, linked faces, rotate. Let's do 10 degrees. Oops, not 10 degrees, too much. You can see there, here, you can see double edges, double edge with a really small face area. To avoid that, increase the distance, 0.001. Distance go to 0. The soft minimum is 0.001. You can go past that, but you can go 0 by manually uh, entering it. So 0.001 is the default. Let's increase this to 0.001. There, you see it? The edges or one of the edge gave way and just disappeared. Or you can do it. Let's make it example more extreme, more obvious. 0.001, 0.01. There. See it? One of the edge gave way and disappeared when you increase the distance. So you can use this to clean up the cuts, or without using this 0.001, you can use remove doubles. The remove doubles will only affect the selected areas and not affect the entire mesh. The only problem with this is that it will change the geometry. So for example here, if we increase the merge distance, you can see that it's merging the verts but also messing with the position of the verts. So you can select between the two, but of course the most optimal one for getting rid of for cleaning up the cuts is the distance parameter. 0.01. There we go. And let's create another example using cylinder. Auto smooth. So now you can see my dilemma when it comes to writing the documentation. The documentation purely focuses on how the script works because I think that's important. Rather than showing you uh, using the add-on artistically is up to you. But what I'm showing you is how the script works in order for you to uh, know how they know the inner workings, and based on that, use the tools properly. So we have here a bunch of ngons. You can already see the distorted faces here. So we want this example. So let's try this. Let's offset this a bit. Offset and also this one. So they're not straight. It's got so but using the default value. Okay, so there we go. Using the default value. We can clean this up by increasing the distance. You can there's a chapter in the documentation on how to what controls to use in the redo panels. You can drag, manual enter values, use control middle mouse button, drag roll up and down to increase the value, something like that, or shift or control drag to increment the values, or shift control shift drag or shift drag to slow down the increments of the values. So I'm using shift drag right now. There we go. And there's another stray here, so we have to increase the distance as well for that. There we go. So we can use this to clean up the cuts for minute offsets of the verts. But be careful in using too much because this will eventually uh, get rid of the most of the cuts like you see here. So I use it to repair the topology when I'm using the operator on curved surfaces or cylinders. So the only weakness of the tangent information is when you, since it's most optimal on angular faces, when it comes to curves, since we're using the tangent information for the cuts in the surface level as well as below. So this is the cut from that. If we choose another, see, so that direction is this of the tangent of this face, I think. So just be aware of that. And then this actually works on rounded caps. I'm not sure why. Look, but uh, there's no straight. There is no straight um, edge here. They're all curved. Look, I don't know why. If it works, don't fix it. So you can actually use combine remove doubles and distance to clean up the cuts for those offset points. So for two edge verts, basically from the last video, these are the verts that only have two edges. So it will get rid of that as you cut, but not this. Prior to the operator, um, having the distance properties, using the quad slice sometimes creates points like this. So I added this to get rid of that. But since the the distance property has been added, uh, the existence of the manifestations of the two-edge verts from using the quad slice operator has been close to rare. So just use it if you want to get rid of this vert. So two-edge verts, remove two-edge verts, which has zero angles. Okay, so what else? Quad slice. Okay, so another thing with I haven't figured this out, but sometimes selected doesn't work, and when you press selected, it will it won't work. As in, it will cut the entire face, like you've selected the all faces option in geometry or length faces, but when you selected, it won't work. It's I haven't figured out why it does that, but if it does that, you can just save the file, turn off Blender, then turn it on to refresh it, and then this will work again. It's a tangent, and I think we've covered almost everything. I think. Let me see if I forgot something else to tell you. Sometimes I remember it when I've finished recording the video, and that is. Oh, this one. Panels. So this is a great example. Let's increase the cut, flip the center, increase the depth, and create a. There we go. So this is mostly quads, but if you choose to use the 12 edges, this is what it will look like. And if we use the quad slice operator here, using the default 0.001 and linked faces, you can see that it cut this one here because depending on the tangent formation, of course, the cut is straight, and it also cut this one here. Cut this one here. But again, distance 0.01, 0.05. There we go. Let's select the coplanars and quad slice there. So do you see what's wrong with the distance? As you increase it, it gets rid of some of the lines, but it also messes up with the direction. So that's with the lines removed from there. But if we set it to the default, we have these straight cuts. 0.05. But that's okay because they're quads, right? But to avoid that, that's happening because we've selected all the faces and decided to cut them all. And since we're using linked faces, every island is affecting each other. And if we use the default, you can see this line here is this edge here, or this vertex here. And if we use 0.05 distance versus, you can see the twist here. Oops, coplanar. So you can see the twist here versus using this island as solo. This is because it didn't have to get rid of the line here. Okay, so just be aware of those situations. So why does it matter for the faces to be um, linked faces? For the faces to be for the lines to be straight, because Shift G coplanar, it will affect the output of the random operators. You see this edge here is kind of bent or slanted. That's because the source of the face, or the face that it's originated from, is some of the edges are also slanted versus this having a, so everything is straight. So in the documentation, you're going to read the part where I said that the output of the random operators is greatly affected by the phase pattern or the topology or how you design it. So, so for example, this box here versus, or this base mesh here versus this base mesh, cursor selected, or active element, straighten this out. Let's get back to median point. So this base mesh here versus using it on this base mesh here, which has a bit of a design. So the outputs are generally much more interesting depending on the design that you have. But since the random operators are affected by the resolution of the base mesh, then you really have to balance between the optimal uh, low poly and the design to have a more interesting result. If the base mesh has too many faces, then you can select faces by sets, or and not use the and not select the entire face, or just select faces by region and apply the random operators to them, just to limit the amount of faces that you have to work on in order to avoid slowing down the operation when using the random operators. So for something like the overlord model that I posted on Twitter. Okay, so this has primary to secondary shapes and some tertiary, but I've set it to render by in this distance, so I didn't need too much tertiary, and most of it are provided by micro displacement, or texture. But if I need to zoom in, or I need a render that is much closer, and I need geometric details that are geometric details in the tertiary level, then I need to zoom in. So in this area, for example, zoom in, and then quadify, just length faces. By the way, um, quad slice cuts from the vertices, but you get this. All of this is it's quadded, but the faces are not evenly spaced. So you have grid project for that. But this will be for another video because this has also has uh, a learning curve. Okay, so I just switched to using either the two link flat faces and then enter the um, tertiary details. Slowly going in or getting smaller and smaller. So you need to balance between textures and geometry. So a good thing about this tool is that the geometry is no longer a problem for you. Closer here. This is probably too much, so I can just manually dissolve this and then so it gives me this. So I don't need to actually qualify the entire island. I'm just going to use selected. Okay, so that's how you use quad slice just like in my video. Okay, so uh, I hope I covered everything. Oh, excuse me. I hope I covered everything, or at least the important stuff. You can read the rest. If I miss something, you can read the documentation. But um, I think that's it, and we can move on to the next video. So this is a very powerful tool. Oh, yeah. Sorry about that. Last one. See, I almost forgot. I I always remember at the end of the video. Good thing I didn't end this. So it works well on curved surfaces as long as the faces are planar. So for example, we have an ngon here, and we need to qualify that. Boom. But for this structure, even though the faces are planar, they are turning, and this is the limitation with the tool, and also for grid project as well. Flip in gone. it won't turn. So X, even if it tag the verts, and use this faces here, quad slice tagged, limit to X and adjust it and remove doubles. There. Well, it connected the 2 points, but doesn't really look right. So, what do we do for this kind of situation? Well, you can use vanilla tools in Blender. Control R, J, select this, J. So, in order to supplement the limitation of the, or defeat the limitation of the tool, of the grid quad slice and grid project, use the inherent tools in Blender, like the knife. The knife in 3.0 is actually pretty good. Uh, K to activate the knife, A to activate snapping. Can actually, when you press A, you can see here constraint is 30 degrees. Press A again to deactivate, and press A to activate. And after that, you can press the number for the angle. So A45, wait, A45. There we go. So now it will snap on 45 degrees. But if we use A5 degrees and then press A again, so A5, 5 degrees. There. A5 degrees. It's kind of clunky trying to activate the uh, numerics, but it works. A 30 degrees, uh, A 15 degrees, A 15 degrees, A 15. Yeah, clunky. There we go. Press A again to shift to snap on midpoints. So what did I do to qualify this? I used the knife, and I use on the first one I use loop cut and then J to connect the verse. So since this faces are quads, I can use loop cut to create a line here, and then these two here I can join them using J or connect verts. Same here. Let's create an ngon and let's turn the face. So quad slice, oops, verts, all faces, linked faces. You can see that it cuts straight. So from here it doesn't work well. So we're only going to cut from this. So selected, and from this point we're going to use the knife tool. Okay, so it works well on curvatures, but as long as they are straight, the faces are straight. Once the faces turn on the plane, on the plane, then the tool of course fails because it optimally work. The cuts are straight. Okay, so I think that is it for the quad slice operator. and I'll do a video on the grid project next. Okay, so that's it, and I hope you learned something from this video. And if you have any questions, use the comment section or the links in the description, or join the Discord in the I've listed the link invite link in the documentation at the end of the documentation. And yeah, you can ask me questions. Just leave your questions there, and if when I read it, I'm going to answer it. Okay, so that is it. Thank you for watching, and you have a nice day and a fruitful and a happy new year. Okay, bye.